Hello, geometry students. Pardon the poor audio quality of this file. I don't have my normal microphone with me. But anyway, we are getting into a little bit of a discussion, a review, preview, if you will, of solving equations. So please copy down the title as well as our objective. And our objective is to review or preview the procedure for solving equations in order to be better prepared for the basics of Algebra 2. Based upon the results of the quiz that we took the other day, it seems pretty obvious that we cannot continue to ignore our problem-solving skills. You absolutely must have a solid mastery of the 5 steps to solving an equation if you hope to have any success whatsoever, either in Algebra 2 or having to repeat geometry, or really any math class going forward whatsoever. So you've seen this information before, but it's obvious that we need to talk about it again, so here it comes. Alright, the 5 steps for solving an equation. The 5 steps start off with dealing with any type of a multiplication issue that may exist in the problem. Typically, that tends to show up in the form of parentheses or brackets or things like that. The second thing that we need to concern ourselves with is combining like terms. And by saying combining like terms in this step, we are saying that there may be things on the left that are considered to be like terms, or things on the right that are considered to be like terms, and those need to be combined. There's no reason for them to be written separately. And just a little refresher, when are things like terms? You have to have the same variable with the same exponent, and of course always the same denominator if there are fractions involved. The third step for solving equations is to pick a direction for your variable. Now, if you already only have one variable in the problem, then chances are you will let it stay where it is and continue on with the 5 steps. So this is referring to the possibility that there might be a variable on the left side of the equation and a variable on the right side of the equation, and if they are on 2 different sides like that, you're going to pick one direction or the other, and you're going to send the variable that direction. It does not matter which direction you choose. It is completely up to you. You will get the right answer no matter which direction you go, as long as you don't make any mistakes. Now in step 3, you made a decision to send your variable one direction or the other in the problem. And in step 4, everything else is going to head the opposite direction. So for example, if in step 3 your variables went left, then everything else that is not a variable is going right. And then lastly, we have the 5th step, which I call the 1 and 1, and that refers to the coefficient and the exponent of the variable, meaning if you put all of your x's on the left, that at the end of step 5 there will only be one x, and it will be to the first power. 1x to the first. That's your 1 and 1. Now, of course, I've got my silly little explanation to try to help you remember it. Parents' complaints vary for everyone. The reason I wrote this or picked this is because the first few letters of each of the words in the acronym are very similar to the first few letters of each of the 5 steps. PAR from parents for PAR in parentheses, COM in complaints for CON in combined in step 2, and so on. If you can follow these 5 steps while not breaking any of the other basic rules that go along with algebraic terms, then we can solve most equations. Now, what other basic rules am I talking about? I'm talking about when you can or cannot combine like terms, having the same variable with the same exponent before you try to add or subtract them together. I'm talking about knowing that a negative times a negative is a positive, or that if you're adding 2 terms that have different signs, you're supposed to subtract the numbers and keep the larger sign. These are the basic rules that have been pounded on you for the last 3 or 4 years And for some reason, some of you have still chosen not to learn these, and you have basically chosen to not be successful in math classes unless you find a way to finally learn the facts of math that you've been told to learn. Okay, so some of the other rules, okay, just some basics, and this is one that absolutely we need to learn at some point in time. And you're going to find this to be even more true as you move forward out of geometry into Algebra 2. The calculator was a wonderful tool as long as we were just adding a couple of numbers together. Okay? The problem is that as you go further into mathematics, the less you know about math and the more you know about the calculator, the less questions you're going to get right. Okay? The calculator is only as smart as the calculator operator. If you do not know any math rules, then your calculator is going to lie to you on a regular basis, and you are not going to know that it's lying to you. That calculator is not some magic box that has all the right answers in it just waiting to tell you. Okay, that is not what it is. That is not what it's intended for, and you will not be successful if you intend for the calculator to try to do your math for you. And you will see that on a very large scale in Algebra 2. So if you've had a habit of ignoring all of the math lessons over the years, going, oh, I don't need to learn how to do that because the calculator can do it, your run of luck is just about out. Okay, so put the calculator down. Okay, on the parentheses, okay, step one, dealing with parentheses, is the distributive property, typically. Okay, so the distributive property basically tells us that if you have a value or a polynomial that is trying to multiply times another value or polynomial, then each term from the first value or polynomial must multiply by each term from the second value or polynomial. Now that's a very long explanation for something that really does not amount to something that's really all that difficult. Okay, and here are some examples that I showed you at the beginning of the year, but I'm going to show you again now. You have on the left side of the problem, we have a monomial, which is the 5, being multiplied by a trinomial, which is the x plus y minus 3. Since 5 is multiplying times the set of parentheses, then it must multiply times everything inside of the set of parentheses. So it must distribute to hit the x and the y and the negative 3. Okay, in the center there, we see a binomial being multiplied by another binomial. Once again, we have something multiplying by a set of parentheses. That means everything from the first set of parentheses must multiply by everything in the second set of parentheses. So we just kind of start off with that a in the left-hand binomial. It must multiply times the c and times the d in the second binomial. Once the a has multiplied by everything that it can multiply by in the other set of parentheses, then we scooch over to the b and we do the same thing. The third example there just makes a simple point that if you do have fractions involved, either in the value that is doing the distributing or in the parentheses that are being distributed into, okay, numerators must hit all other numerators and denominators must hit all other denominators. That is simply a fact of mathematics, and if you do not do this, you will absolutely miss the question. And back to the very first obvious rule, if you do not know how to perfectly ask this question of your calculator, it absolutely will not get the answer correct. And unfortunately, that means a lot of you will just copy down the wrong answer because you think that calculator is so smart. Another thing to keep in mind while we're talking about the distributive property and talking about the calculator right here, right now, is this. Okay, some of you still seem to think that the calculator knows what x is. Well, x is variable. It changes every single problem. So how on earth would the calculator know what x is? So if you took your calculator and like on that very first distributive property down there, and you type 5x plus y minus, 5 times x plus y minus 3, your calculator can have that typed into it. And you can press enter, and it will give you an answer. And there is zero chance that the answer it gives you is going to be correct, because your calculator does not understand what the value of x is. It does not understand what the value of y is, but it assumes that you know how to ask the question correctly, so it gives an answer. It's just not the right answer. Step 2, combining like terms. Okay, this is something we talked about briefly a moment ago. When are terms actually considered to be like terms? Well, there are 3 conditions that absolutely must be met in order to be able to add or subtract terms, and that is exactly what's happening in step 2. Now, I've already touched on these things. This hasn't been tremendously important in geometry, but you better believe it's going to be very important in Algebra 2. You better make sure your terms are like terms. Okay, so first off, the first condition that must be applied is if you're going to add or subtract 2 variables, they had better be the same variable or the same group of variables. And you will start to run into more than one variable in your problems in Algebra 2. Okay, and if you do not have the same variable or the same group of variables, then you cannot add or subtract those 2 terms together. That means x's do not add and subtract with y's. X's only add and subtract with other x's. Y's only add and subtract with other y's. And further, in Algebra 2, you're going to see a lot of this, where you have an x to the first in the problem and also an x squared in the problem. Those will not add or subtract together because of the next qualification. The variables must have the same exponents. This means that x to the first cannot add or subtract to x squared, and so on. Okay, so once again, if this is not true, then you cannot do the addition and subtraction. Those terms must stay apart from each other. And as always, all the way back to like 4th and 5th grade, if you have fractions going on with your coefficients, then they absolutely must have the same denominator in order to be combined. Now, unlike the first 2 qualifications, this one can be fixed. We can find a common denominator for our fractions, and once we have a common denominator, then we simply keep that denominator in our answer, and we combine the numerators by the addition or subtraction that the problem says to do. Okay, so there's the final part of what I said. Combine the coefficients and keep the variable the way it is. Okay, now when I say keep the variable the way it is, what I'm saying is if you take x's and you add more x's, you still have x's. It does not become x squared or y or anything like that. Okay, it is simply combining. You have some x's and then you have some more x's, and then you combine them together. You still have x's. The only thing that can change the exponent on a variable is multiplication and division. Okay, now not to beat a dead horse, but just to go back to the most important rule, the calculator. Your calculator does not know any of these rules. Okay, like I said, the calculator is only as smart as the calculator operator. If you do not know these 3 qualifications and you just type it up in your calculator will give you an answer. It's just not any chance that it's going to be the right answer, because your calculator does not know. You must be smarter than that stupid little box that we think is so smart. Steps 3, 4, and 5 are not all that difficult to understand because they basically all operate under the same premise. And the premise that they operate under is that sending your variable one direction in the problem, sending everything else the other direction in the problem, and then acquiring a +1 coefficient and a +1 exponent for your variable, all are centered around sending things from one side of the equal sign to the other side of the equal sign. This is just the order that we do it in. In order to accomplish sending things from one side of the equal sign to the other, you basically only need to remember one critical step, and that is to do the opposite of whatever the problem says to do. If something is already being added, then the only way to stop it from being added is to do the opposite operation of addition, which would be subtraction. By subtracting it, you counteract the addition. Okay, same thing. If you have something that is being multiplied and you want to stop it from multiplying, you must do the opposite of multiplication, which is division. Multiplication and division will cancel each other out. And what you will find is that in mathematics, most things have an opposite. Just about anything that's going on in a problem, we can do something that will counteract it. Okay, but one thing that you've absolutely got to do is, since you are changing the problem, you are bringing math into the problem that is new, something that was not there before. If you are going to do something new to the problem, you absolutely, positively must do the exact same thing to the opposite side of the equal sign. Now, the other side of the equal sign did not want that to happen, but that's not the problem. The problem is we changed one side of the equal sign, you have to change the other side exactly the same to keep the equal sign balanced. Okay, so some basic information here. What's the problem? Okay, will you always need all 5 steps for every single problem that you run across? Okay, the answer to this one, I think everybody knows by this point, is no. You do not need all 5 steps for every problem. But the 5 steps that I have there, parents' complaints vary for everyone, that is your please excuse my dear Aunt Sally for when it comes time to solve equations. We're going to look for parenthesis and multiplication problems first. Then we're going to look for combining like terms problems. Then we're going to look and see if the variables need to be combined to one side of the equal sign. Then we're going to look for moving everything else away from the variables. Then we're going to look for the 1 and 1. And if you look for those things in that order and do them correctly, you are going to get the right answers more than 99% of the time. So no, you don't usually hardly ever need all 5 steps to solve a problem. You usually only need 2 or 3 of them, but you got to get them in the order that they're supposed to be gotten in. Will you ever see things in a problem that are not mentioned in the 5 steps? Yes, absolutely. Guys, these 5 steps, I have kind of simplified and dumbed them down as far as a human can simplify something, to try to find a way to get you to memorize the very basics. Okay, there are 100 things that could show up in a problem that aren't specifically mentioned by parents' complaints vary for everyone. So what will you do when you run across those things? We will learn to apply certain things into certain steps. We will learn, okay, here's this thing that shows up in the problem. Where is that going to fit in? Oh, well, that fits into the combining like term steps. And we'll go, okay, well, we'll do that when it comes time to combine like terms. You simply incorporate these new things into the 5 steps, and you learn as you go. Will everything I see in an equation have an equal opposite so I can move it to the other side? Meaning, is there anything that'll ever show up in an equation that is impossible to undo? Okay, yeah, there's some things out there. Okay, there are some things out there that once they show up in a problem, or once we do something to a problem, we damage the problem. Okay, and it's an unfortunate situation, but guys, what you probably don't realize yet is we do not have, and when I say we, I'm not talking about just you, I'm talking about mathematicians in general, we don't have a total understanding of the mathematical universe. There are things that are broken in our understanding of math, and that's just the way that it is. Okay, so what we have learned to do is we have learned to counter some of these failures. We've kind of put definitions on them. We understand that they are there, and you will start running into a few of these little failures in Algebra 2. How will you know if you get the equation right or wrong? How do you know if you get the answer right or wrong? Well, when you get all the way to the end of a solving equation problem, you should end up with something like x equals 2, y equals -3, g equals 0. Whatever the problem is, you will end up with a variable equals a number. How do you know if you've arrived at the correct number? Okay, if you think that x equals 2 or y equals -5 or g equals 0, then you take that value back to the original problem and you take that variable out and you put that number in its place. If the equation ends up being balanced, meaning plugging that number in gives a true statement like 5 equals 5 or -9 equals -9, then you have plugged a value in that the equation likes, and that must be the correct value. If you plug it in and you end up with a statement like 2 equals 3, then either we haven't plugged in correctly, or the value that we did plug in, the equation did not like. There is never any excuse to miss a solving equations question because every single one of them are checkable. Okay, that's your basics on the 5 steps of solving an equation. We're going to spend a few days hammering on this, trying to make sure that we have it. It is kind of an inexcusable situation that we are still in a spot where we do not understand how to solve an equation. You've been doing it for too many years now, so if you find yourself in a spot where you just don't get this, you need to get it in gear and start working seriously in order to get this resolved. Anyway, I appreciate you finding time to get your notes taken care of. I apologize that ran a little bit long today, but I'll see you in class.